The adapter design pattern is a structural pattern that converts the interface of one class to the interface of the client. It's quite intuitive. You adapt one class to be able to work with a given interface. So specifically, the problem is, a component offers nice functionality but is incompatible with the system you are developing. Your plug simply doesn't fit the socket. So let's look at an example. I'm going to have a band app which is able to play different instruments via the perform method on different musicians. And some third-party system offers nice sounds which I would like to use, but it doesn't do it with a perform method interface. So I can't just simply go there, call the third-party musicians via the perform method and get what I want. So as a solution, we create an adapter which wraps the object you want to use, so the so-called adaptee, and invoke its method in the adapter method. So we're creating a suitable socket for our plug. The solution we're aiming for looks like that. We're going to create an interface musician which offers the perform method we want to use as a standard method to invoke the sounds on the musicians. Then we're creating a adapter. In this case, I'm just going to do one example for the guitarist adapter, which wraps of course, a guitarist class that can play guitar to make the guitar sound. And I'm using aggregation, so I'm wrapping a guitarist class inside of the guitarist adapter class. And when I call the perform method, inside of that, I actually invoke the play guitar method of the adaptee. But let's also look at the code to understand this better. Okay, here's the interface, straightforward. Then we're going to do 3 sounds we want to use. So we're getting access to a guitarist, a pianist, and a singer. And they all look the same. They have a name, constructor that assigns a name, and then they have a play X, play their instrument, and a getter method for the name. So they're all in the same shape. The pianist plays the piano, the singer sings. Okay, so we want to use those classes, but we want to just call those classes with the perform method. Okay, for that we're creating the adapters. So the guitarist adapter will take in the adaptee type guitarist. With the constructor we assign the adaptee. And then in the perform method we say, hey, use the adaptee's method play guitar to get the sound actually going. And here in the implementation I'm just printing the name of the musician and is playing the guitar or whatever their instrument is. Same for the other adapters, same structure. They take an adaptee. The pianist adapter of course takes a type pianist as an adaptee, assigns the adaptee, and then uses the play piano method. And same style for the singer, just uses the adaptee.sing method. And then as a demo, we're going to create some sort of a band. So we have a list of band members which are of type musician. I'm going to create a new singer adapter. To instantiate the singer adapter, I have to pass a singer. So we have to instantiate one inside of here. I'm going to name it Ozzy. Same for a pianist and a guitarist. We wrap it in the recording adapter. Our pianist is called Vicky and the guitarist is called Richie. And then we can just loop through the list of band members and call the perform method, and we get what we want. We designed the system to be workable with the perform method, right? And now we can use all those third-party classes with the perform method instead of calling all the individual methods play guitar, play piano, and sing. And that works fine. Just to see the difference how we would do this without the adapter classes, we could just take the classes from the third party, so the guitarist, pianist, and singer, just the same as before, just without the adapter classes accordingly. And then in a demo, what we would have to do, we would have a list of band members, but of type object, and we just simply instantiate the simple classes without an adapter. But then, when we want to play the band, so we loop through the list of objects, we have to check for the type, and then we have to typecast, and then invoke the individual methods. So that's a little bit more difficult, and you can imagine if we design a system that is supposed to work for perform, that's not what we want. So it's easier to do the adapters, and then we get what we want via the perform method. And you see, if we do this, it results in the same output, but it's a little bit more messy.